So I can begin. Hello, everyone. Today I would like to tell you about such a thing that economical people and accountants don't even know about. It's called 200 open source projects after. So we have conducted big number of open source projects. We have accumulated certain knowledge on the basis of this, and we have noted a lot of interesting things that we'd like to share with you. The fact is that economical people, financials, they don't even understand how bad the situation is. They are living in such a ignorance world. They want to take their head and say, well, no, everything's good. People think that speaking about security, they would like to think that everything is normal and they have no errors. But it's very interesting. If you will take the statistical analysis methodology, it's a wonderful things that you can see. And who am I and why I'm telling you about all of this? I'm Andrei Karpov. I'm one of the developers of the statistical analyzer, PV Studio. Maybe you've heard about it. And one of the ways of the promoting of this product, we check in big number of open source projects, big amounts, closed projects, but I'm speaking about open source projects because we can speak about them. We don't have NDA signed. So we have tested more than 212 open projects, and among them there are big known. So we have a big vision about what can be the code. I think it's going to be interesting for you. In more details, you will be able to go to our internet site and learn about those errors. You will read articles about it, but it's afterwards. Well, right now, I would like to tell you about 7 interesting observations that we have detected about how people program, the 7 sins of programmers. It's going to be interesting from the point of view of security and training, and you will learn something new. Otherwise, I could call it 7 sins of programmers. Let's begin with a simple one. Programmers sometimes are confident that compiler is at fault. If something is unclear, they say, well, it's a problem of compiler. Compiler is at fault. Why did I face that? Because the fact is, while studying the errors in projects, it's often that next to these errors, I can see certain comments which tell me, do you know, this code, I've made a patch here, or this, but, you know, it's a problem with the compiler. An example, that's how it looks like. Mem set, we clean it, would like to clear certain structure, but we're making the size of this. The first bytes are cleaned and everything else, but what the human does? The human is unhappy. He says, this doesn't seem to help after optimization. In the debugged version, it's zeros, but in the release version, compiler is having problems. So he says manually he fills all the fields with the zeros, so he won the 0. Then he tells all the programmers how he was fighting against the compiler, and he's confident that it's not him at fault but the compiler. It's a similar observation that I've noticed, and I've seen many things like that. Next one. There's another observation. Sometimes you can see some historical layers which were happening with the project. For example, dinosaurs were living and then meteorite have died and then dinosaurs have died off. So some people in their projects also was doing something. For example, you can see, for example, you have moved from a char to teacher, right, to white symbols, or from malloc to new, you've been transferring, or from 32 to 64 bits. And I will give you a couple of examples. Falling of the meteorite, you move to TCHAR, you have changed all the oils, you have changed it, but then you forgot that you've been working with those. And malloc gives the quantity. Well, in the beginning, the number of symbols was normal, but then you have 2 times less buffer. And then suddenly, well, it still works. For example, if the lines are short, everything's processed well. But if you get very long lines outside of the array, and you see that this is oil in certain application, a lot of mistakes like that. The next meteorite files, somebody have decided that it's much better for him to go to the new, operate new instead of malloc, but he forgets that new is not returning bots, but it looks at the exception that something was wrong. But processors were old, as they were with the malloc previously. 0, not 0. If 0, then you should clean something. New limits, new closures, you have replaced it. You looked at the mass malloc, you have replaced by new. Well, application works, generally speaking, until something was wrong. Next one, a big layer, is a transition from 32 to 64. Program generally works. You have replaced the types, everything's normal, but then some magic begins. For example, the function receives the word PTR, shall be type, shall be platform, but in the given case, it says the work applications being casted. Then afterwards, dword has been recasted, and dword is shells. Well, the program works for several years, everything's wonderful, but God forbid memory object will be created outside of first gigabytes of memory. Then you cut the second part, and you receive uncertain behavior. These programs, they make assumption that they work, but it only seems that they work. The next observation is the effect of the last line. I've been reading that mountain climbers, they fall on the final meters of lifting, not because they're tired, but because they just have relaxed, they are at peace, or a little bit have left, they are joyful, and they lost attention, and then they drop. Same people with financial people, when they do copy pasting, they are very careful. One line was copy pasted, second line was copy pasted, 3 lines was copy pasted. But in the last line, they have not changed it, and it's such mass character. I paid attention. I write about this in the article. Here's an error in the last line. Please pay attention to the last line. And I figured out it's a big mass project, and in different projects you could see something like that. Inches or some other X, Y, Z, Z alpha channel should be done out there. In this case, same thing. One line was copied, pasted, but they forgot to amend it. QT, same thing. You should check for variables X, Y, W, but H you have forgot. So big number. And I got so interested in it. I was checking the statistics. I've collected the statistics, about 1,500 examples where they had typical blocks. I've calculated, and I figured out that if we have 5 similar copy-paste were done, there's a high probability that in the last error line there will mistake. They make a mistake in copy paste, modified, but on the final line, on the final copy paste, they have 4 times more errors than in previous ones. Then let's go to the observation number 4. Programmers think that they are smartest. Well, it's not arguable question. It's true. They are often know a lot of things, because if the user comes to them and asks them who was doing what and when, and something happened by itself, but they know that, well, nothing happens by itself. They like to get to the core of the problem. They always think that they are right, and they get used to being always right. But there's a negative side to it. If programmers are wrong, it's very difficult to convince him that he's wrong. Especially it is difficult to do by some software instrument. For example, if some programmer says that, well, you have an error here. He said, no, it's not an error. Never, 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 never. It's a bad tool. And it's a mass situation. It's a big problem. For example, we've been checking out of an instance of Wolfenstein 3D project. Simple error, functional problem. The matrix has to be copied 3 by 3, but the error is here that this pointer, size off from the pointer, returns the pointer. So it's not an error, but a pointer was specified. So 3 people were writing, some people left comments, somebody been writing, your analyzer is wrong. Even in an article I have explained them why this is an error. Look here, it's an interesting example. They said, no, you're wrong, you're wrong. Even if they don't believe an article, do you see how low is probability that a person will believe an analyzer when he will say that in this function there's an error? He won't believe the analyzer. He will say, no, it's the wrong analyzer. Everything's wonderful. Same example here. Out of the mail discussion, there's a certain array of chars, and there was an extra naming size of char. One char is brought to 0, the other ones stay as they were before. Mem says, and the person writes, it's a false statement in this line, as many bytes as in the first element of the array. Well, it's painful to tell him, but it's very difficult. So I have to prove to the people that they made mistakes. But sometimes it's very difficult even to show it with a tool. So no, if they say that it's a problem with compiler and analyzer, read it carefully. It's a common mistake, number 5. Security. Well, it's a security-related conference. Security. But who tests this security? It's a rhetorical question, but the fact is that nobody ever checks all different mechanisms in their code which have to defend something or clean something, etc. And the simplest example here, there's an array where we're encrypting something like 64-byte encryption. Well, the same error, like in the previous example from another program. They put a star here in vain, then size of char, 1 byte is filled, everything else as was, it is, certain private data stays in the memory. Well, it's half an error, half a memory. It's even worse with the function mmset. The fact is that compilers today, they are very clever and smart, and they love to optimize. Well, it's wonderful because they work very fast, but for example, compilers remove functions which from the point of view of the compiler are necessary. What it means, the function is not needed. Compiler knows how the memset function works. That's why if some buffer is being cleaned, but then it's not used in any other function, the compiler, from the point of view of C++ language, this memset does nothing, right? From the point of view of the language, if this memset will be removed, nothing will happen. But from the point of people, there is sense. We have a certain private data buffer, and we have to clean it with zeros before leaving. But the compiler removes this memset, and this happens so often. It's awful. We have been discovering in many projects, for example, in PHP, in the end, it was, for example, they have cleaned a certain buffer, they have left, and this line disappears after the compilation of the release version. And even here, you see that this memset is not available. The compiler have compiled, but the memset is not available. In Linux, this error happened. We have checked the kernel of Linux. After we have informed them, they have replaced this memset by a special memset explicit, which really cleans. And there are special functions for that. In Linux, it's this function, RTL secures the memory. In other ones, it's another one. But the whole problem is that all these projects, after we have checked all these projects, we have found 169 errors like this. I've calculated 169 errors where the buffer has to be cleaned, but honestly, it's not cleaned. So some data is still hanging in the memory, and then somebody can steal them. We have not been. We've been looking for other errors and not these ones. But at given one of them, 169 were discovered, and I've been writing some of them that I've been searching for. Next one. Well, it's not a sin, but nevertheless, it's impossible to know everything. Right? Everybody knows that. But if we would like to write reliable and safe software, we have to learn. No other options. And statistical analyzers can help you from this point of view because they play a role of a certain expert which has such knowledge, which programmer can't even assume that he has such errors in the code, but the analysis can know about the potential defects in the software, in the program. And in different books and articles, they say step cut is an error, mistaken function. Don't use it. You have to use str and cut. And people use, but usually they use it wrongly because nobody reads it carefully, str cut. Because it says that the final parameter defines not the size of this buffer to which you copy, but how many more can be copied to it. So in mass, I see code like this. They think that they have specified by the last argument the size of this buffer. No, it says that we still have 2048 symbols and we have 2048 symbols here. And then we have code like this afterwards. So basically speaking, you can write like previously, and that wouldn't be different. As it was dangerous, it stayed dangerous. Well, some people know about that. They write size of minus control and file name. But it's closer, it's almost good, but still, it's still -1. Nobody comes to the full expression, to the full proper expression. Another interesting example, char is not bool, so if something moves somewhere, it doesn't work as it should work usually. Let's see, this is a synthetic example that I was writing in order to be brave. There's a memcmp, something compared with something, then it returns not complete but char. And this is a true vulnerability, and you can follow the URL. It was in MySQL bug. We have not diagnosed it, but at that moment in time we have started our analyzer and we could find it back then. But what is the main idea of it, this error? There is no guarantee that memset will return minus or 0 or 1. It returns less than 0 or more than 0. More than 0, this could be 256, for example. When you put 256, you will put in char, it will be 0. So it means that they are equal. So such realizations do happen, and therefore people don't know about it, but it's available. Observation number 7. In search of silver bullet. You know, some people look for some reason for a silver bullet. You shouldn't look for this silver bullet. There are different ways and approaches, and we need them. For example, there's a course overview, development through testing, dynamic analyzers, statistical analyzers. There's no single method which could replace all other methods. Well, in principle, you can say that a code overview can replace all other methods, but it's not practical in real life. So right now I'd like to demonstrate to you, so each one of these methods is vulnerable and you should use all of them. So what do I see in tests, in unit tests? Unit tests and statistical analyzer discovers very often errors in tests. For example, nobody writes it for the tests, so something crazy happens over there. Here's another example, fragment from these particular tests. For example, we have certain logic. We have tested, for example, if it's included, we'll do it. But afterwards, the person wanted to comment something. He doesn't need his actions. He commented them. But what did happen? Right now, this if, it's the topic of this if, because it's related here, and the test will not be launched. It will be started only if this condition will be executed. So there is no test, actually. We have no test. Basically, we're omitting this test. As for the code overview, it's like this ophthalmology table. In when you see smaller, 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 and then suddenly you don't see. So first 5 minutes you're attentive, 10 minutes you're honest, 15 minutes you want to have coffee, and in 20 minutes you have to finish, otherwise it's not going to make any sense. So it's impossible for a human being to do that, to overview the code, or it's too expensive. You have to ask people to work with little breaks, etc., etc. Then development will be 10 times more expensive. And it's still not a fact that people will listen attentively. So when you look at something like that, OpenCell. Oh my God! And I've made an example, only a small example. We had many examples like LSCF, and the eye doesn't see any errors. The eyes don't want to perceive this code, don't want to perceive. But analyzer, he doesn't get tired. He is not in a hurry. He looks at it and he says, "Why you have it here long lines, and this one you compare only 3 bytes?" Well, the person who made a mistake, just simple copy paste. It's a copy-paste mistake, as I've told you. He took perhaps this line, copied it here, hex replaced by this bit list, but 3, as it was 3, it became 3. So we compare wrong things. And it's almost unrealistic to see these errors. And I did see a lot of fragments of code like this. Somewhere parentheses is improperly installed. It's difficult to perceive. Next, what dynamic analysis cannot do. It's not a salvation from, it's not a silver. For example, you didn't put a parenthesis in the right place. Then we have a size of, it's not even to 0, we get 1. You should compare 2 bytes, but you compare only 1 byte. From the point of view of dynamic analysis, no error. We have not left the threshold of the memory. Everything was initialized, but for some reason, person should compare function mem_cp 1 byte. The code is absolutely correct, but some errors, in principle, they cannot be cached by dynamic analyzers. From their point of view, everything is correct, but statistical analyzer can see those errors. They also have statistical analyzer also is not a silver bullet. An example, for example, is there a threshold of the massive or not? For example, we have read certain numbers. It's a synthetical example that I've made. And in statistical analyzer has no data, and for the dynamic analyzer will catch this error during execution. So we'll give some data, it will analyze it, and then we'll have output outside of the array. And statistical one will not see because it is not executing the program. But if it executes the program, it's dynamic analysis. So this is an example. By this I show you that all tools have their own deficiencies. So don't try to find a silver bullet. Use them all in complex. Tools are different, they all are important, and we produce one of those tools. And right now, another thing that I would like to give you about usage of statistical analyzers. Well, it's right, it's a very important part. And the wrong method how you can use analyzer is to take and check the code. You have checked it and said, well, everything good, wonderful. No. This analogy is like errors of compiler. You have not switched all the compiler's warnings, and then you program for 1 year, you're checking you do the debugging, you catch all the bugs, it's painful, and then once a year you have switched the warning and then corrected them. No, wrong. The meaning of warnings is to correct it as early as possible. The same with statistical analysis. It's actually an extension of your work, of the work of the compiler, to discover certain defects deeper, more precisely. So by launching analyzer regularly, you catch errors at the early stage possible. At the moment when you bring it, it doesn't even come to the tests. They all are tests, but the big number of the same typos can easily be catched. That's why it is important to do it regularly. It's a fast example. The same thing, for example, you take a book, War and Peace, you put it in Word, you have checked the orthography. Well, it's not clear why you need it because everything is right. Why? Because correctors have been correcting it. Some other methods have been testing. Well, it makes no sense. But if you type new text in the Word, and then it's much more useful, right? Well, thank you very much for your attention, and I'm ready to answer your questions. How much time we still have left? Yes. What? Speak in the microphone, please. We can't hear you. Hello, thank you very much for your presentation. I was always interested, obviously, in your analyzer you use for diagnostics pattern matching method in your statistical tree, right? Is that true? Well, we build a tree, not abstract synthetical tree, but for us it is important to have different joints which from the abstract point of view are external parentheses, but we need all these external parentheses and other things because we need to know everything, because it gives us certain hints, and then by making a pull through the tree we collect certain information, but every diagnostical analysis is unique and it's different from point to point. Yes, it's understandable, but it's interesting to me, do you use any internal representation or more complex meta-analysis like some simple data flow analysis? Roughly speaking, if you have 2 pointers and they are placed in different locations, well, aliasing is not considered for us. There's a simple data flow, but statistical analyzers are very limited. They cannot do everything. If they start passing and emulating big volume, they work very slow or very bad. But if some Bluetooth will meet, then you can stop it and forget about it. Yes, available, but very limited. In principle, this is the problem of statistical analyzers. Some people do it deeper, some people do it shallow, but it's very difficult. Yeah. So you don't build IR, mostly on syntaxes. Well, there's a big number of observations, and users say that they discover some things. We read some examples, and some patterns are repeating often, so we try to realize them in the search. And we're more concentrating on typos discovery. We use some empirical methods when we look at the code and we start making assumptions with different matrices. For example, in same copy-paste things, we build certain matrices, and when we look at some anomalies in the matrices, everything was good here, and then suddenly stands out some repetition. Maybe it's a typo. And it's a very rough explanation, but nevertheless, that's how it is. Okay, thank you. Thank you. More? How regularly should the scanning be? Well, the ideal option, incremental analysis, you have done the compilation automatically in a background mode. Usually how it is done, analyzer has been started and then it works. If it comes to a warning, then you see a warning window. Please pay attention to this. Is the ideal option, and then use this warning. If you cannot do like that, for example, you are not developing in Visual Studio, you can preset during compilation or night assembly. So we receive the report and we check ourselves every night. We check ourselves and then we receive this report by email. I don't like answering this question because it's very easily can be reduced to a common level, because you know how it usually happens when some macros is not successful and gives a false positive 2000, but we suppress these macros and then 1900 have disappeared. So in the morning you have to spend 4 hours to analyze it. Well, this is the end. Individual, I will tell you which mechanisms we use for this. Yes, thank you very much. To expect that historical analysis will become commodity. Inbuilt into compiler. They are inbuilt in compilers. For example, in Windows they have PN, and for some objectives it's sufficient, but professional products it's like Photoshop, which costs money. Well, this is my analogy. Who invents those rules? There is no list of those methods that have to be realized, but users constantly send some things to us. Different users and potential users, they write to us that perhaps there's something in it and it should be done. We also develop some things when you read some things, when we develop some things. There is no formal process. I don't hear question. Common purpose about 230. Plus we have shell bit rules, optimization rules, but they are not as interesting. That's it. Thank you very much. I was glad.